I hope all of you have understood how to find electric field with a point charge. In the field of point charge, to find the strength of electric field, we need to keep a vanishingly small test charge over there. The force experienced by the vanishingly small test charge per unit charge is known as electric field strength at the point. Instead of one, if there are two charges, then in each superposition principle, we find the vector sum of the two fields. Field into one charge plus vector sum that field into the other charge. Today's class, I will be discussing electric field strength due to a continuous distribution of charge. Hello everyone, MK here. This session will find how we derive a method, how to find the strength of electric field due to continuous distribution of charge. Continuous distribution of charge means charges come one after the other, they are in contact, there is no distance of separation into consecutive charges. Due to the charge distribution this manner, how to find the strength of electric field at a point we are going to discuss now. Before we start calculating electric field strength due to continuous distribution of charge, we state continuous distribution of charge refer to a scenario where charge is spread continuously over a line, surface or volume rather than being concentrated at discrete point. See in this diagram, there is continuous distribution of charge here. Why? Along the length, all the charges, suppose some amount of charge Q you have distributed. Then we will assume that the charge is distributed uniformly over the whole length of the wire or rod. Suppose this rod has finite length, you have given a charge Q to it over the length L. Length is L. Then we will define its line density of charge because it is one dimensional situation. Along the length of the rod only charge is distributed. So line density of charge will be lambda equal to Q by L. What is the unit of lambda? Unit of lambda will be coulomb per meter. Okay. So here some amount of charge distributed over the whole length. Sometimes net charge is not possible to find. Just line density given. That is the case of infinitely long wire. Due to that infinitely long wire, to find the value of lambda if it is not given, you will consider a portion of it. Imagine that this rod is of infinitely long and you want to find the line density of charge not given over there before you find the strength of electric field at a point. The method we will follow here, we will take a finite length here, we will find the amount of charge here and then lambda will be defined by the same formula if this length is L. So line density of charge will be defining whether it is given or not. We will find it by using this formula. It is charge per unit length. Unit is coulomb per meter. Let us see what is surface density of charge. In this picture you can see that there is a disc. It is charged uniformly. Charged uniformly means per unit length, not length here. This will be per unit area, charge will remain the same throughout the surface of the disc. This time surface density of charge will be defined as sigma equal to charge distributed over the whole surface area. For this circular disc, surface area A equal to pi r square. So the value of sigma going to be q by pi r square. Okay. If sigma given, your problem is to find the strength of electric field at a point on the axis. In the previous case, we will find the strength of electric field on the axis, no, not axis, at certain distance away from the charge rod. There may be volume density of charge also. Over the volume, whole volume of this non-conducting sphere. What is the difference between conducting and non-conducting sphere? We have taken a non-conducting sphere here. If you give some amount of charge at a point, it will remain over there. It will not come to the surface. But if it is a conducting sphere, whatever amount of charge you give there, that always will appear on the surface. So this time, charge is given to the whole volume of non-conducting sphere. Its volume density rho can be defined as charge given divided by, if this sphere has radius equal to r, q divided by 4/3 pi r cube. Okay. What will be the strength of electric field inside the sphere, outside the sphere, and what is the graph of electric field versus distance? All these things we are going to discuss today. The first problem, okay, before discussing the problem, let me tell you what is the general technique for finding electric field due to continuous distribution. It's a very common method in some problem in moment of inertia. This you have already used. When you want to find the electric field due to the charge distribution given here, maybe along the circumference of the ring, maybe along the length of the wire. What you have to do there? You need to divide the whole wire into infinite number of small parts. Okay? Divide the continuous charge distribution into infinitesimally small elements. Why? Why you are dividing? Because there is no formula available for the charge distribution on the whole rod. But if we divide mentally, of course you are not going to divide in parts or infinitely many parts. If we divide into infinite number of small parts, I mean mentally, then each part can be considered as point charge. Due to that point charge, we will find electric field at a point, and then by integration we will find for the whole rod. Similar is the case for this charged wire. Okay? Without wasting time, and another thing, I told you that when you have assumed that the elemental portion is carrying a small charge, it is like a point charge, then for electric field that formula E equal to K into dq by r square is to be used. Okay. So without wasting time, let us do it for line density of charge first. This one-dimensional case I am going to show you how to find strength of electric field at the origin. You have kept it along x-axis. This is the diagram here. This one is charged. It has finite length. The length we are assuming equal to L. You have given a charge which is distributed uniformly. Before you calculate, this is our basic assumption. You never forget that. We divide the whole charge. Suppose the charge given is Q. Over the length L we have distributed. So line density of charge will be what? Lambda equal to Q by L. You are supposed to find the electric field at this point. At the point O. Assume this one is the origin. The distance of this end of the wire, it is JB, the wire, charged wire, is L0 from origin. We are taking X and Y axis this manner. direction of x-axis. You have to find the strength of electric field at the origin. Okay. So what you will do there? You will follow the method. You will divide the whole charge, whole rod into infinite number of small parts. This is an elemental part which is representative of all the parts of this wire. How much charge is there that we need to find? And then we will find electric field at O due to this elemental portion. Elemental portion we are taking as PQ. This elemental portion is at a distance x from the origin and it has length dx. And we are interested to find on the x-axis at the point O. Right now we are not going to find it along y-axis. So this elemental portion carrying how much charge that you need to find. Elementary portion, it has line density of charge. You have taken lambda, which is total charge divided by L. If total charge not given, lambda given, that also fine. So this elementary portion is of length dx. Length is equal to dx. So amount of charge on this elemental portion will be equal to lambda into dx. That we have taken dq here. dq is lambda into dx. And after dividing into infinite number of small parts, this charge dq is a point charge now. Due to point charge at a distance x, the strength of electric field you know. And since this one is positive charge, this is positive, now all the charges are taken as positive. So due to elemental part, due to the elementary portion, electric field at O is going to be dE. It is one dimensional case, it will be directed this way only as it is positively charged. dE equal to dq by 4 pi 0 x square. This is nothing but lambda dx by 4 pi 0 x square. Now this dq, all these dq will contribute. So to find the strength of electric field at the point O, we need to integrate the expression. E will be integration of lambda dx by 4 pi 0 x square. Okay. But this wire has finite length. You should integrate between two limits. What is the limit of integration? It is going to be L0 at this point. X is L0. At the end here, it will be L0 plus L. So integrate over this length from L0 to L0 plus L. Keep lambda by 4 pi 0 outside. L0 to L0 plus L x to the power minus 2 dx. Outside it is x to the power minus 2 plus 1 pi. So there will be lambda by 4 pi 0 minus 1 by x L0 to L0 plus L. Just put upper limit. Minus minus plus 1 by L0, upper limit minus lower limit. You take lambda by 4 pi 0 as it is and then multiply. Take the LCM. This will be what? Minus L0, L0 plus L. So the electric field strength at origin we found as E equal to lambda into these two get cancelled. L divided by 4 pi 0 L0 plus L. Understood? This is the strength of 4 pi L0. 4 pi L0 should be there. This multiplied by L0 plus L. Okay? So this will be L0, L0 plus L. Clear? This is the value of electric field due to this charged wire. At some point, L0 on the left side of the left part of the wire. I hope you have understood. Now let us find electric field strength due to a charged circular wire. For charged circular wire, let us start with this problem. This is a semicircular wire. Its line density of charge we are taking lambda, which is equal to Q by L if the charge given and radius obviously known, then L will be pi r. So lambda going to be Q by pi r. Your problem is to find electric field at the geometric center of the semicircle. We'll apply the same technique. We'll divide this wire into infinite number of small parts. Okay. Then we take the existence of an elementary part of it. Elementary part is like this. This is the elementary part. Due to this elementary part, we have divided mentally into parts, and this elemental part carrying a charge dq. What is the value of dq? That I'll let you know. Your problem is to find electric field here due to this elemental portion. You join it. Join this also. This elemental portion is PQ. Due to this elemental portion PQ, the electric field will be directed this way, no? In what direction electric field will be directed? Due to this elemental portion, electric field will be directed radially outward. And this field has two components. Component along x-axis, component along y-axis. Okay? This problem, let us solve with the help of the vector, because this has two components. If you consider the location of this elemental portion is at an angle theta from here, this angle you are taking theta, this portion is theta and this one is d theta. That elemental portion is small. So orientation will be like this. About this radius, you have taken the elemental portion PQ, where it makes an angle theta with this diameter, and d theta for this elemental portion. Okay. So electric field at O due to this elemental portion we need to find. How to do it? D value will be what? D value will be dq by 4 pi 0 r square. Radius of this ring we have considered r, so it will be dq by 4 pi 0 r square. What is dq? We have taken this d theta and this is theta. We will remember one trigo formula here, that arc PQ will be equal to r into d theta. Like in trigo you did know, for circular wire. For circular wire, if this has length dl, this one d theta, this is r, then d theta you have defined what manner? D theta will be dl by r. The same manner we are going to find the value of arc length. Arc length is what then? PQ. This arc length is equal to r d theta, and then amount of charge on the elementary portion will be what? Amount of charge on the elemental portion PQ on PQ will be equal to dq. That dq is what? Lambda into length of PQ. Length of PQ is r d theta, so lambda into r d theta. So dq is lambda r d theta. So electric field at O due to this elemental portion electric field at O due to PQ is equal to dq by 4 pi 0 r square. Isn't it? What is the value of dq here? dq is lambda r d theta. Lambda r d theta by 4 pi e 0 r square. R are getting cancelled. So it is lambda by 4 pi e 0 r into d theta. This is the value of the electric field, not PQ. Sorry. This is dE. dE equal to dq by 4 pi 0 r square, lambda by 4 pi 0 r square d theta. But this is just magnitude. Electric field is a vector quantity. For every elemental portion, direction will not be like this. For this elemental portion, it is directed this manner. Contribution of other elemental portion also there. Their result will be added. You get it by integration. No issue. So let us find the electric field in vector form first. At this point, I am writing dE vector. This is total magnitude. It has two components. It is lambda by 4 pi e 0 r. Component in this direction will be dE sin theta. And this direction, the way I have taken theta, it will be dE cos theta. Okay? Now dE equal to lambda by 4 pi 0 cos theta. This way you take the vector j cap and this way you take I cap. You have taken two-dimensional coordinate this way, or if you take this one as y-axis, then you take this one minus j cap. So the strength of electric field at the point is going to be lambda by 4 pi 0 r cos theta d theta. In this direction it is I cap. No, this way it is sin theta. So it will be sin theta d theta I cap. This plus cos theta d theta j cap. Alright. If you write vector form, it will not be j cap, it will be minus j cap. So take minus sign before. Okay. And d theta is multiplied over there. D theta has to be there. Don't leave d theta. Okay. Everyone got? This way it is I cap, this way j cap. So strength of electric field like this. So E you write this way. E equal to lambda by 4 pi 0 r. We need to integrate sin theta d theta. There will be I cap. Minus cos theta d theta, there will be j cap. Alright. Now what is the limit of integration? See, to cover the whole length, if this is your initial line, you have rotated by how much? 180 degrees. So limit of integration will be 0 to pi. Here also it is 0 to pi. So let us find it. It is lambda by 4 pi 0 r. How much is this? Integration you don't put. Sin theta integration is minus cos theta, you know. Alright. This minus sin theta j cap 0 to pi. One thing very interesting to note that this sin theta component getting cancelled when you put upper to lower. So this is lambda by 4 pi 0 r minus cos pi, that is 1 into I plus 1 into j, and this is going to be 0. Okay. So E equal to, sorry, lambda by that I into, oh my god, one mistake is done here. Just a minute. This is lambda by 4 pi 0 minus cos pi is 1. Minus minus plus 1. This is one thing. Minus sin pi is 0. 0 j cap. This is I cap. So it is going to be lambda by 4 pi E0 R into 2 I cap. Alright. This is the value of electric field due to a semicircular charged wire. What we have done? We have divided. We have considered the elemental portion. We found electric field due to that elemental portion. Then by integration, we get it for the whole semicircular ring. It is given by lambda by 4 pi 0, 2 pi 0 r. In what way it is directed? It will be directed this manner only. D sin theta exists. D cos theta getting cancelled. Okay. Tell me what alternate way we can understand this concept. But not today. Let me do the next derivation here. Due to electric field due to a charged quadrant of a circle. Okay. We are going to solve third problem here. There is a quadrant of circle. Your problem is to find the strength of electric field due to this charged quadrant of circle. Okay. How to find it? This one is a charged quadrant of a circle, part of wire, circular wire. We have taken one quadrant of it. I mean 1/4 length. If the radius is r, then length of this wire is going to be pi r. Okay. It is charged. Line density only we are discussing now. This line density of charge is lambda. Your problem is to find the strength of electric field at O, at the center of this charged quadrant of circular wire. Alright. So what will be the method you are going to apply here? You divide into infinite number of small parts. This is an elemental part PQ. Okay. It's carrying some charge. You take the angular position of P like this. This one theta. And this one is d theta. Okay. Your problem is to find strength of electric field at O. And this total angle is pi by 2, obviously, because you have taken quadrant of circle. Now we fix up our x-axis this manner. Unit vector in this direction be I cap. Then we fix up y-axis this manner. Unit vector will be j cap. Your problem is to find electric field due to this elemental portion whose angular position given this way. AB is the wire. PQ is the elemental portion. Like previous sum, PQ length will be equal to R into d theta. If the radius is equal to R, it's carrying a charge dq equal to what? Lambda into its length. Lambda into R d theta. Okay. Now the electric field here has two components. This is the reaction of electric field. If this one is theta, this is theta, component this way will be d cos theta, and this way it will be d sin theta. Okay. And electric field at O due to this elemental portion, electric field at O due to PQ, this elemental portion is equal to what? It is dq by same way 4 pi 0 r square only. And this is written scalarly. We want to write it in vector form. But how to write in vector form here? D vector I am writing now. D vector is what? D, what is the angle with x axis? Cos theta. plus d sin theta into j cap. D sin theta this way, it will be j cap. Alright. Now put the value of d, calculate each part separately. So this is going to be, what is d here? dq by 4 pi E0 r square cos theta I cap into sin theta. But there is a problem here. You have written, no, it's okay. Because you have taken x-axis, positive x-axis, unit vector that direction I cap, negative positive y-axis is j cap. So it is into j cap. Correct? Because unit vectors this way, d also has two component along x-axis and perpendicular to it. Now put the value of dq. dq is what we have calculated before. dq is lambda r d theta. So lambda r d theta, I mean cos theta d theta by 4 pi E0 r square d. This plus dq is what? Lambda into r d theta by 4 pi E0 r square sin theta into j cap. So due to whole wire, how much rotation is required for this initial line? Very easy. From 0 degree to 90 degree. It is over because it is quadrant of circle. So let us find E equal to, you keep this thing outside. Lambda r by 4 pi E0 r square. The limit of integration cos theta d theta will be what? This limit of integration will be from this end, from the end OA, and rotated by 90 degree. Then OB is over. So it will be 0 to pi by 2. This thing will be what? 4 pi 0 r square sin theta is integration 0 to pi by 2 sin theta d theta. Now integrate. This is, oh sorry, d theta by mistake. So lambda r by 4 pi E0 r, another term going to be cancelled, not required now. Sin theta 0 to pi by 2, and this will be lambda by sin theta is minus cos theta 0 to pi by 2. So this will be what? Lambda by 4 pi 0 r sin 90 degree, that is 1, and this way it was vector I cap. Sin theta integration, I mean cos theta integration done, put upper limit minus lower limit, 1 minus 0 I cap plus lambda by 4 pi 0 r. This is what? Cos pi by 2 is 0 definitely, minus minus plus 1 plus 1. Okay? And this is into this j cap. You have lost somewhere, it is j cap. Okay? So there will be lambda by 4 pi 0 r, what? This plus this, but this is I cap and this is j cap, lambda by 4 pi 0 r j cap. So electric field at this point has two components. That E you have got, E equal to what you have got? Lambda by 4 pi 0 I cap pi 0 r into I cap plus lambda by 4 pi 0 r into j cap. Alright? So net electric field, how do you find? Net electric field you can find just by vector sum. Vectorially I have written. Mod E, how do you find? Mod E will be this square plus this square. Simply. Lambda by 4 pi E0, you take common, E0 R into unit vector mod E. Okay, modulus of this thing will be this square plus this square. Let me write. Lambda by 4 pi 0 R square plus lambda by 4 pi 0 R square. So this will be lambda by 4 pi 0, not R square, it is R. R E. E we are finding this multiplied by root 2. So final answer lambda root 2 by 4 pi 0 R. Written over there. Alright. So electric field on the axis of the semicircular charged wire is given by this thing. Lambda root 2 by 4 pi 0 R. Alright. In this problem, a part of circular arc is charged and this angle is equal to theta. Okay. Portion of charged circular ring we have taken. This is also charged. Your problem is to find the strength of electric field at O provided this angle is equal to theta. This total angle is equal to theta. Okay. How to find the strength of electric field at O? Process is similar. What I discussed with you earlier problems. We will divide mentally into many parts. For an elemental portion, you will find electric field here and then by integration for the whole wire. But before you find electric field due to this thing, you need to divide into two halves. Calculation will be easier as I have seen before for this sum. I am sharing idea with you to find it. To find the strength of electric field here, we just divide in two halves. Total angle theta, so this portion will be theta by 2. This portion theta by 2, this portion is also theta by 2. Okay. Here to find electric field here, we just imagine that this portion. So after dividing it, I have taken the elemental portion PQ here. This is the elemental portion PQ. This OP makes an angle alpha with the vertical one. We have divided with that, it makes an alpha. This elemental portion makes an angle D alpha. Charge on this portion is dq equal to lambda into r into d alpha. Because length of this portion, if the radius is r into d alpha, that I told you before also. Write the expression for electric field now. Due to this elemental portion, it is dq by 4 pi 0 r square. Dq is what? Lambda into r d alpha by 4 pi E0 r square. This is the value of d. Again, this time we need to consider two coordinate axes. What are those two? That is x and y. We have taken along negative. This has angular position alpha. This portion d alpha. These are taken as x and y axis. Okay. Imagine this is your x axis. This one y axis. Unit vector this way. J cap this way. Instead of taking negative I, negative j, I have considered positive x axis this manner, this, so that you can take this portion of charged circular ring in such a manner that this one looks like x axis original and this one y axis. It's up to you. I have taken x and y axis this way. So dE magnitude we have written. we have to write d vector. How to? D vector will be this way cos alpha j cap, this way sin alpha j cap, d is component. So d sin alpha I cap plus d cos alpha j cap. Alright. Now let us write the value of d over there. So d going to be what? D vector is lambda r, this value we are putting here, by 4 pi E0 r square plus lambda into r by cos alpha d alpha j vector. This one is I vector. Okay. We have to cover the whole where we have started from here. So limit of integration you have to decide. This way, let us do like now d will be what? 1 r get cancelled. So lambda by 4 pi E0 r common. Then what will be there? Sin alpha d alpha cosine. Sin alpha d alpha, this is I, plus lambda by 4 pi 0 r common, cos alpha d alpha into j. Isn't it? The next step is choosing the limit of integration. So if we integrate both sides, d integration is e lambda by 4 pi E0 r integration sin alpha with I over there d alpha. Limit of integration will be what? Initially you are dividing two parts, theta by 2 and theta by 2. Now this is the radius vector. Radius vector rotates in clockwise sense. Theta by 2 angle described. Anti-clockwise sense, another theta by 2 is defined. So taking clockwise negative, anti-clockwise positive, the limit of integration we are taking minus theta by 2 to theta by 2 plus, now this thing is what? This thing is j cap. So there will be lambda j cap by 4 pi 0 r, and this is also minus theta by 2 to theta by 2 cos alpha d alpha. Clear? So this will be, just integrate. Sin alpha integration is what? Tell sin alpha integration minus cos. So E equal to lambda by 4 pi 0 r, sin alpha integration is minus cos alpha (4 pi 0 r). This is sin alpha. Okay. Now upper limit minus lower limit if we put, then E going to be equal to lambda I by 4 pi 0 r minus cos theta by 2 plus cos of minus theta by 2 is theta by 2 only. So this get cancelled. Lambda j by 4 pi 0 r sin theta by 2 minus sin theta by 2. So another sin theta by 2 will be there. So the answer is this part vanishing. E equal to lambda j by 4 pi 0 r 2 sin theta by 2. You can keep your answer this way. So I hope you have understood this. This one is bit problematic, but once you start practicing the sums I am doing here, it will be convenient for you. This one is a charged rod of finite length. We want to find electric field at this point due to this charged rod. Okay. How to find? See, with respect to this point, angular position of these parts changing. If you say that, we'll follow the principle, divide the rod into infinite number of parts due to an elementary part you find and then get it by integration. It's fine, we'll do that only. But we have to take a strategy where with respect to this point, the whole length of the rod is going to be covered. How do you do that? This is the point. From P you have drawn a perpendicular. Here this rod has line density of charge. Line density of charge is lambda. You want to find electric field at a distance A from the rod. So from the point P where you want to find electric field, you draw a perpendicular. PM is the perpendicular. Okay. Now, angular position of the points of the rod being changed. So if this is our elementary portion, this part is elementary, it is PQ or AB, whatever you have taken. AB is the elementary part. Its angular position with respect to the point P, and this ends angular position with respect to the point P, B, theta and theta plus d theta respectively. This is small angle. Imagine that the angular position of these two extremities of the web are like theta 1 and theta 2. This angular position you have taken theta 1 and this angular position you have taken theta 2. Now due to this elementary portion is where? It is of length dx, the way you have taken previously, at a distance x from M. M is the origin here. So electric field strength at the point P, will be directed this way. This is your x-axis and this one is the y-axis. Unit vector this direction is I cap, in this direction it is j cap. Now this angle theta means this one also theta. D is the strength of electric field. So component this way will be d cos theta. Component this way will be d sin theta. And if we write the way we did before, that electric field d vector as component along x-axis plus component along y-axis, then it will be d cos theta I cap plus d sin theta j cap. Understand? Now what is d? Same as before. dq, the charge on this elemental portion, dq equal to lambda into dx. So electric field at P, just the magnitude due to elemental portion, dq by 4 pi E0, this distance be r square. What is r square here? R square is a square plus x square. This r is obviously variable. dq value is lambda dx. Just substitute there. 4 pi E0 a square plus x square. This is magnitude. Cos theta sin theta, if you want to write in terms of theta, you can write, but we'll avoid here. Because you have taken angular position theta 1, theta 2, you should express everything in terms of theta 1 and theta 2. How to? Let us write the value of this lambda dx by 4 pi 0 a square plus x square. Cos theta sin theta I am not changing here because angular position I have taken. Our aim is to express it in terms of theta. In this diagram, what do you observe? That x is equal to a tan theta. Okay? So dx is a sec square theta d theta. And a square plus x square, just substitute there, it will be lambda a sec square theta d theta by 4 pi 0 a square plus x square going to be a square 1 plus tan square theta, which is nothing but a square sec square theta. Okay? Just substitute there. So d value you get in very convenient form. It is lambda by 4 pi E0a into d theta. Isn't it? Now let us write the value of dE here. Okay? That d vector will write. D magnitude we got here, lambda by 4 pi 0a d theta. Just substitute there. So d vector is d cos theta, lambda by 4 pi 0a not a difficult one. Lambda by 4 pi 0a cos theta d theta plus lambda by 4 pi E0a sin theta d theta j cap. Okay? Now, here you see theta is changing from where to where? This way, if you want to cover theta becoming this sense. If we take this one negative, this has to be positive. One of them negative, the other one positive. So if we start covering it from here, we go down, take my theta 1 negative quantity, theta 2 positive quantity. You will ask why? Because this PM when rotate, one rotation is in this sense, anti-clockwise, the other one is in clockwise sense. So we are taking theta 1 negative here because sense is different here. So just put the value over there. E going to be equal to integration of, you keep lambda by 4 pi 0a common. It is common to both. Cos theta, I forgot d theta. D theta is there. D theta is there. Sin theta d theta. I have taken for one. Other one I forgot. So cos theta d theta, this I cap you take out. Minus theta 1 to theta 2. I have explained why. Plus lambda by 4 pi E0a minus theta 1 to theta 2 sin theta d theta, and j you take here. Just integrate lambda by 4 pi E0a cos theta integration is sin theta minus theta 1 to theta 2 lambda j by 4 pi E0a minus theta 1 to theta 2. Just to upper minus lower, lambda by 4 pi E0a sin theta 2 minus sin minus theta 1 is plus theta 1. So it will be sin theta 1 plus lambda j by 4 pi E0a. This one negative, minus minus plus. So cos theta 1 minus cos theta 2. Okay? So for this infinitely long where let me draw the diagram here for your better understanding. So for this finite length of wire where this one minus theta 1, this one theta 2, electric field at P is given by lambda the line density of charge, this distance A, it is lambda I by 4 pi 0 A sin theta 2 plus sin theta 1, lambda J by 4 pi 0 A cos theta 1 minus cos theta 2. Okay, this is general expression for electric field due to finitely long wire. Now, if we want to get it for infinitely long wire, how to cover the whole wire if it is infinitely long? You are going to put theta 1 90 degree, theta 2 also 90 degree. So the value of E going to be what? E going to be lambda I by 4 pi E0 A sin 90 plus sin 90. And this part lambda J by 4 pi E0 A lambda J by 4 pi E0 A cos 90, so this part 0. This is lambda I by, I cap you root, that 1 plus 1 2 pi E0 A. So electric field at a point due to infinitely long wire at a distance A from it is given by lambda I by 2 pi 0. See how nicely you can derive once we have an expression like this. Okay, for the whole length of wire it is infinitely long, then we put theta 1 theta 2 90 degree, we get the value. Now the question is, what will be the strength of electric field at the end? This is at any arbitrary point due to infinitely long wire at a distance A. Now, if we consider P here, P is lying here. Suppose P is considered at one end and it is infinitely long. Then the value of theta 1 going to be 0, but theta 2 is 90 degree. So if the point P lies at one extremity, correspond with one extremity, then how to cover infinitely long wire? We have to take theta 1 0 degree, theta 2 90 degree. So just get the value of E from this calculation. It is going to be, you just put theta 1 0, theta 2 90. So lambda I by 4 pi E0 A, this plus theta 2 90 means 0, and here lambda J by 4 pi E0 A. Okay, so if the point P lies at one extremity, then electric field will exist. It is infinitely long wire going this way, infinitely long. At one end, electric field we can get by using this formula. Okay, lambda I by 4 pi 0 A plus lambda J by 4 pi 0. So electric field will exist both the way, both along x axis as well as along y axis. But this time resultant field will be mod E equal to lambda by 4 pi E0 A outside mod I plus J, that is lambda root 2 by 4 pi E0 A. I hope you have understood.